So this last topic is about taking a variable expression. So this is a bit of mathematics that includes numbers, operations, addition, subtraction, multiplication, and division, but also variables, right? Variables are proxies for quantities whose value we might not know. And we're going to sit a lot with variables this semester. As you probably know, algebra is largely about how to manipulate variables using the principles that make arithmetic work. And our first exposure to how variables work is right here, where what we're doing is getting practice taking an algebraic expression and specifying values for its variables. And then figuring out what value that expression has as a result of the values of those variables. So among these 5 problems, which one of these 5 would you most like to discuss as a large group today? So looking at number 5, we're given this expression xy over x plus y, and asked to evaluate this expression for the values x equals 1/4 and y equals 3/4. So what's your process, first of all? What are you doing? What would be your step 1 in your strategy for solving this problem? Plugging in. But when you plug in, here's a recommendation that I make. Whenever you are faced with the task of plugging in numbers into an expression. So let me rewrite what the expression was up here, xy over x plus y. And we know what values we want x and y to have in this example. But my recommendation is the following. That before you just go putting numbers where letters used to be, to pause for a moment and introduce some empty sets of parentheses where the variables used to be. So in place of x, I'm going to put an empty pair of parentheses. In place of y, I'm going to put an empty pair of parentheses. And I don't know if this problem will provide us with the opportunity to appreciate why this is an important step or not, but I'm going to do it here anyway, because it's always my recommendation. Anytime you're plugging in values, start with an empty set of parentheses, and then fill in those parentheses with the value that you want. So since in this problem x is 1/4, we'll fill in 1/4 in these x parentheses here. And since y is 3/4, we'll fill in 3/4 for the y variable. And the great thing about the plug-in step is as soon as the plug-in step is done, this is no longer an algebra problem anymore, right? Which should be good news for everybody. Anytime variables have left the building is usually a much happier time than when they're here. And so now our job is just to treat this like a problem from earlier in Module 1, which would have just asked us to evaluate this numerical expression. So tell me about that process. Looking at all the arithmetic happening here, what would you like to evaluate first? Yeah,
The multiplication.
let's work on the multiplication. Why is that a good choice?
Well, because that's harder.
In this example, I think you're right. At least the end result is a little trickier when we do this multiplication that's on top versus the addition on the bottom. We might not know that up front, but if we do, you know. There's another reason, by the way, to choose multiplication to do before addition. What is it?
MS.
Yeah. It's kind of what I was fishing for, but I'll take both. You're right. Okay, so let's do the multiplication here first. By the way, where is the multiplication in this expression? Because I didn't write any multiplication signs. Yeah, this is maybe one reason why including parentheses might be a good mental cue for you. Because if you just write the 1/4 and 3/4 next to one another without parentheses, you might accidentally miss the fact that what we're doing with those two numbers is multiplying them together. Okay, so we know now that in the numerator we're multiplying 1/4 by 3/4. How do you multiply fractions? Straight across. So straight across the numerator, straight across the denominator. So what's my new numerator going to be? 3, sorry. My new numerator is 3, the new denominator is 16. 1 times 3 over 4 times 4. And so if I continue now to the next line, what I'm going to have is upstairs the fraction 3 over 16. Okay. One of the things that makes this problem look daunting, though, is that we've got fractions within fractions happening. So we're going to have to reckon with that at some point. But let's try and put that off if we can. and look at the addition problem happening in the denominator. How do we add 1/4 plus 3/4?
Just add the
Yeah, well, how do we know there's not another step to do here?
Will we have a common denominator?
We already have. This is like the best kind of fraction addition problem. We already have common denominators. We don't have to go searching for different denominators to rebalance these fractions. They can come as they are, and we can just add. And when we add, what do we add? Yeah, just across the numerators. And what denominator will we use? Right. So upstairs we end up 1 plus 3 is 4. Downstairs my denominator remains 4. And so once I've done this addition, my overall expression here is still 3/16 upstairs, 4/4 downstairs. Now I want to go back to Robert's point about why the denominator is easier than the numerator in a moment. But first, what's your question? So I'm going to follow Brian's recommendation here. His question was, is there a way for us to take what we call in the business a compound fraction, fraction within fraction, right? Can we write this so that it's on a line on a horizontal instead of stacking big things with a bunch of different sized fraction bars that provide us with the opportunity to screw things up? And the answer is yes, sure. After all, what operation of arithmetic is a fraction bar really indicating? Division. So why don't we take this big giant fraction bar, which is dividing the fraction on top by the fraction on bottom, let's just turn that into a division sign instead. Now, it bears mention that the division sign doesn't get used a whole lot once we get into algebra for reasons that we might appreciate a little bit later on. But I think here it's a good reminder of what we actually want to do with these two fractions. What we want is to divide the dividend, the numerator of this gigantic fraction, by the divisor, the denominator of this big fraction. And so turning it into a fraction division problem written out horizontally reminds us what's really going on in this big fraction. So I think that's a good practice. Anytime you're trying to put one fraction over another, which doesn't happen very often in our course, but it certainly could. Right? And now that this is a fraction division problem, how would you like to proceed? How do you divide two fractions? Gabby?
You flip the second one, and then you change it to multiplication.
Yes. A few of you, when you took the Module 1 quiz on Monday, attempted to divide fractions by doing some cross-multiplication hoop-dee-doo. If you tried that, you were certainly not alone. I hear a few chuckles. But as I recommended to one of you, cross-multiplication is a dangerous game. There is a way to achieve division of fractions by cross-multiplication, but you'll probably screw it up. So I recommend not doing that, but instead following Gabby's advice. Flip the second fraction. Replace that second fraction, here we call it the divisor, replace it with its reciprocal, that's the fancy term for flipping a fraction upside down. And when the divisor is replaced by its reciprocal, division is replaced by what operation? Yeah. So turn it into a multiplication problem. Multiply by the reciprocal. 3/16 times, well, this fraction happens to not change when we flip it upside down. In fact, what is 4/4? Yeah, why don't we just simplify that before we move on? Right? 4/4 is just 1. And what's 3/16 times 1 going to be? 3/16. There we have it. So in the beginning, this problem was an algebra problem. You're given an expression and told to provide specific values for its variables. And as soon as you do the plugging in step, creating empty parentheses, shells, and then putting the numbers in their places, it then just becomes an arithmetic problem. And any arithmetic expression, like the one we started up with here, the order of operations will tell you how to evaluate it. And the only caveat, and the thing that made this the most intricate of the problems that you had in your groups a moment ago, was this compound fraction happening here. The fact that we had a fraction upstairs, a fraction downstairs, and a fraction made up of those two. And if that ever happens to you again, this trick here at the end is probably the best way to handle it. Turn it into a division problem written out horizontally. Turn that big fraction bar in the middle into a division sign, and remind yourself that what you're really doing is dividing fractions, which you can accomplish by multiplying by the second fraction's reciprocal instead, and turning it into a multiplication problem would just mean multiplying straight across.